You know, hydraulics is one of the most important parts of today's tractors. But too often, it's a subject that's misunderstood and not used properly. So today, we're going to cover the remote hydraulic systems offered on the new Ford 3, 4, and 6-cylinder tractors. We'll show you how they work, and we'll point out their advantages. For a hydraulic system to work, it needs two things: pressure and flow. And while you can't completely separate these two items in the hydraulic system, you can separate what they give you. Pressure is force and flow is speed. The pressure is measured in pounds per square inch, or PSI, and it'll determine how much force or how much push the cylinder can develop. It's those pounds per square inch against the area of the cylinder that's going to determine how hard it can push. A flow measured in gallons per minute is going to determine how fast the cylinder fills or how fast it's going to move. So as you change pressure, you're going to change how much force you can develop. As you change flow, you're going to change how fast the system moves. In order to understand how the hydraulic system works, we've got to start with the basics. Now, in a tractor, the system begins with a sump or an oil reservoir where the oil is stored. Coming out of the sump, the oil goes through a suction filter to take out water and impurities. This protects the pump and the valves. Next is a pump that causes the oil to flow in the system. The oil flow from the pump is controlled by a valve or a series of valves that allows the operator to direct the supply of oil to where it does its work, usually a cylinder or a hydraulic motor. Most systems also have a relief valve that protects them from excessive pressure. If the pressure required to lift a load, for instance, is too high, the relief valve opens and dumps the oil back to the reservoir. Otherwise, the pressure could actually build up enough to damage the components in the system. It's also necessary to relieve the pressure when the cylinder reaches the end of its stroke. Most systems also have another filter here on the return line to the reservoir. This is a finer filter than the one on the suction line and removes even more impurities from the oil. Both filters should be checked and changed regularly. And that's a basic hydraulic system. There are many refinements and added features that make most systems more flexible, more efficient, and more complicated, but they all still have these basic elements. And you need to remember that the pump creates the flow in the system, and it's resistance to that flow that creates the pressure. Since the hydraulic pump is the heart of the system, let's take a look at the kinds of pumps that are used on tractors today. Pumps fall into two main categories: fixed displacement and variable displacement. Now, displacement is the volume of oil moved or displaced with each revolution of the pump. Fixed displacement pumps move the same volume of oil with each revolution, and the volume of oil flow changes only when the speed changes. They can be either gear or piston type pumps. Variable displacement pumps can vary the volume of oil they move with each revolution. On the John Deere variable displacement system, the pump's internal mechanism changes the output of oil to try and maintain a constant pressure. When the system pressure drops, volume increases, and when the pressure rises, the volume decreases. A hydrostatic transmission also uses a variable displacement pump, but in this case, the operator determines how much oil will be pumped with a control lever or a pedal. Changing flow changes the speed of the vehicle. Here's a drawing of a fixed displacement gear pump used on Ford tractors and many other makes as well. Gear pumps are widely used because they're very simple and economical. They consist of two gears inside a closely fitting housing. One of the gears is driven by the engine, and it in turn drives the other gear. Oil is drawn into the gear pump and trapped between the teeth and the housing and carried around to the discharge side. Where the teeth mesh in the center, they form a seal that prevents oil from passing through this direction. So oil is continually pushed out into the hydraulic system by the flow of oil trapped between these teeth. The gear pump is simple, rugged, and reliable, with a low susceptibility to damage from dirt and other foreign material. As you can see, there's very little to go wrong with a gear-type pump. Now remember that this is a fixed displacement pump, meaning it's going to give full flow all the time it's running. The pressure in the system is going to change depending upon demand. Now over here we have a variable displacement piston pump used by John Deere. It's about the most complicated pump on the market today. It's a radial piston pump, meaning the pistons radiate out from the center line like the rays of the sun. Some companies use axial piston pumps where the pistons are parallel to the pump's axis. This is called a variable displacement pump because the length of the piston stroke varies as the system pressure varies. This is accomplished with a special stroke control valve that would fit in here. In the John Deere pump, the piston is moved by a cam here in the center part. The engine turns this shaft. As the cam comes around, it pushes the piston up, forcing oil out into the hydraulic system. As the cam continues to turn, the piston drops back down, pulling oil into the piston area. Now if that's all there was to this, it would be a fixed displacement piston pump. But in the Deere system, as the pressure builds up, stroke control valve that would be located here begins to open and allow oil to flow into the cam area here in the center part of the pump. Here it builds up pressure that acts on the bottom of this piston, holding them away from the driving cam. As the pressure in the system builds, it prevents the piston from taking a full stroke, which means then that the pump puts out less oil. When it gets to maximum pressure, the piston cannot move at all, and the output of the pump goes to zero. So in the John Deere variable displacement radial piston pump, the flow varies as the pressure changes in the system. There's more flow at lower pressures and less flow as the pressure rises, and no flow at all when you get to maximum pressure. This compares to the Ford gear pump that pumps full flow at all times, regardless of the pressure. Understanding the difference between fixed displacement and variable displacement pumps is important to understanding the next subject we're going to discuss, which is the characteristics and differences between the open center and closed center hydraulic systems. There seems to be a lot of misunderstanding about the terms open center and closed center, but it's really not all that complicated. What we're talking about when we say open center and closed center is not the whole system, only the design and operation of the control valve itself. Now here's a diagram of an open center hydraulic system with the control valve. And here is a cutaway of an actual hydraulic control valve. Now a valve is a very simple device with one moving part, a spool which slides back and forth inside a sleeve, which is in the body of the valve. The spool has high spots called lands and low spots called grooves, and the sleeve has openings for oil flow. When one of the lands on the spool blocks an opening, no oil can flow through it. When the spool is moved, unblocking the opening, oil flows through the groove area and out whichever opening is uncovered by the same groove. So this is how a valve directs the flow of oil to wherever we want it, by covering and uncovering different combinations of these openings, creating what we call flow paths through the valve. Now in an open center system, when the valve is in neutral, oil flows through the center of the valve. Oil then comes from the pump, through the center of the valve, through the return line, and back to the reservoir. The system maintains full flow at all times, but at a very low pressure, since there's little resistance to that flow. Therefore, at rest, an open center system uses a minimum of horsepower. When the valve is moved as it would be to extend a cylinder, for instance, the land on the spool moves over and blocks the center position, opening the side position and causing the oil to flow along the path to the piston end of the cylinder. Here, the resistance created by the cylinder will cause the pressure to build up to whatever force is required to move the piston. If the pressure required to move the load is too high, the relief valve opens and relieves the pressure by dumping the oil back to the reservoir. Up until the point that relief valve opens, an open center system can produce both maximum flow and pressure for maximum productivity. In a closed center system, when the control valve is centered or in neutral, there's a land on the spool blocking any flow of oil through the valve. The John Deere closed center system uses a variable displacement pump that we talked about earlier. When the control valve is in the neutral or centered position, there is no oil flow through the valve. Pressure then quickly builds to maximum, opening the stroke control valve, putting oil into the cam area of the pump, and holding these pistons up so they cannot move. The pump then stops pumping oil. When the control valve is moved, it unblocks the center position and directs oil around to piston end of the cylinder. As the pressure drops, oil comes out of the cam area of the pump, the pistons begin to move again, and it supplies oil to do the work. Now, there is no relief valve in the Deere system. When the cylinder gets to the end of its stroke, or when it gets more load than it can handle, back pressure through the system once again opens the stroke control valve, putting oil into the cam area and holding the pistons up so that the pump will stop pumping. Now, there seems to be some misconceptions about the John Deere system. For instance, there's an idea that when the system is not being used, valve in neutral, that it doesn't require any horsepower. Now, this is not true. The pump is still turning, so that itself requires some power. There's also some oil being used for cooling and lubrication of this pump, being bled off all the time and running down through the cooler and back to sump. So the pump is working to maintain that flow. It's also maintaining maximum pressure in the system. That requires some power. And lastly, there's a charge pump in the rear end of the tractor. It's a gear type constant displacement pump working at about 200 pounds pressure, supplying oil to this variable displacement pump and for additional cooling. It's running all the time the engine's running, and it requires power. So the John Deere closed center system does use all power at all times, even at rest. Why are there two systems? Well, there are advantages and disadvantages to both. An open center system is simple, economical, has low horsepower requirements at rest, and can provide both maximum flow and pressure at the same time for maximum productivity. But it's really at its best when operating only one remote control valve at a time. If it's operating more than one, it's going to fill the demand of the one with the lowest pressure first, then go on to the next lowest, and so on. In some cases, this can cause a delay in response time, unless the valves are very carefully feathered. Now, a good operator can do this fairly easily on a backhoe, but it's not really practical on an ag tractor. The best advantage of the closed center system is that it's very good for operating more than one remote valve at the same time, and at different pressures and different speeds. Now, this is because the closed center control valve can be designed with a more effective flow control valve than on an open center system. In an open center system, maximum flow is determined at maximum pressure. By contrast, in the Deere variable displacement system, maximum flow is rated at a low pressure, and output will be reduced to zero as the pressure builds to maximum. Notice in these illustrations how flow, in gallons per minute, is affected as the pressure increases. The output of the Deere variable displacement pump with the stroke control mechanism will be maximum at low PSI and zero at maximum PSI. and will be only about 9.5 gallons at 1800 psi. Now compare this to the Ford's constant displacement pump with an output of over 25 gallons per minute at 1800 psi. This means that the speed of a cylinder or motor, when it's operating at high pressures and under a heavy load, will be faster with the constant displacement pump than with the variable displacement pump. This inability to deliver maximum flow at maximum pressure is one of the major disadvantages of the variable displacement pump. And another point to remember is an open center system only builds up to the pressure required to move the cylinder or the motor, whereas the Deere's closed center system, the variable displacement pump, is always trying to build up to maximum pressure. As a result, it requires more horsepower to drive the pump. This is why on 3 and 4 cylinder Series 10 and 6-cylinder TW Series tractors, Ford offers a combination open center, closed center system to provide the advantages of each system: quick response, low horsepower requirements, and the ability to operate multiple remotes at the same time. Now, here's how the Ford combination system works. Oil from the main pump flows through a valve that controls the 3-point system. This gives the hitch priority over the remote valves. Now, this is the opposite of what happened on older model Ford tractors. The main pump supplies more oil than the 3-point hitch will need in many situations, so the excess, and all of the oil when the 3-point valve is in neutral, goes to a priority valve pack, which controls the flow and pressure of oil to the remotes. In addition, on the left rear of the engine is an auxiliary pump that's also connected to the priority valve pack. If the remote system ever needs more oil than the main pump can supply, the auxiliary pump makes up the difference. Both the main and auxiliary pumps on all Ford tractors are simple, reliable gear pumps. Since the remote valves are all closed center with the flow control, they can all operate at different flows and pressures at the same time. A pilot line connects the remote valves to the priority pack. When the remote valves are in neutral, there's no signal in the pilot line. This allows a spring-loaded valve to open, and the oil flows back to the sump, as with a regular open center system. When one or more of the remote valves is actuated, the pilot line picks up a signal, closes a spring-loaded valve, and directs the oil to the remote valve. For more details on the mechanics of Ford's closed center hydraulics, we recommend that you view TrackCom number 6. Ford tractors can be equipped with up to 4 closed center remote valves. Each valve has its own pair of couplers at the rear of the tractor. The couplers are marked lift port and drop port with coated rubber covers. The remote valves have 4 positions: neutral, raise, lower, and float. Each position is detented to hold the valve in the selected position. In the raise and lower position, the valve will return to the neutral position automatically when the cylinder reaches the end of its stroke. And the pressure required to make this automatic return is separately adjustable for each valve. An adjusting screw and lock nut is located on the control valve on the spool body, above the couplers. In the float position, an attached cylinder is able to extend and retract freely and float with the equipment movement. Using the float position also makes lowering a single-acting cylinder easier with today's Ford tractors, since there's very little back pressure. When the control is in the float position, it must be returned to neutral manually. Each remote valve has an easily accessible individual flow control that adjusts the volume of oil going to each cylinder or hydraulic motor to provide individual control of the speed of response or operation. The Ford closed center remote valve can also be hooked and unhooked under pressure. Move the disconnect lever to the up position and plug in the male coupler under pressure into the female coupler. Then move the disconnect handle down, completing the connection. If the male coupler should pull loose during operation, there is no loss of oil through the coupling, regardless of the position of the disconnect lever. Ford closed center remote valves allow the operator to start a hydraulic motor or stroke a cylinder very smoothly under complete control because the valves are very easy to feather. There's a lot more to the new Ford tractor hydraulic system than we've been able to cover in these few minutes. But we've shown you the basics of what we believe is the best hydraulic system available today. The unique Ford combination of open center and closed center system provide quick response, smooth operation, low horsepower requirement. It can operate multiple outlets at the same time. It's the best of both worlds in hydraulic systems, and it's only available on tractors from Ford. Now, if you'd like to learn even more about these hydraulic systems and other things on Ford tractors, come on down to the training center. We're looking forward to seeing you.